Hi viewers, welcome to the 6000X InfiniiVision series oscilloscope jitter demonstration video. In the end of the last video, I showed you how to set up the jitter configuration to random jitter, and we cleared the display, but I've left all these settings the same. Now what I've done is I've injected a 1 megahertz sinusoidal jitter into the clock signal that we were seeing. And to remind you, the clock signal was 15 megahertz. So with the exact same setting, I'm going to let the oscilloscope run. And it should start creating the TIE and collecting data points for the histogram. And if we let it run, you would already notice that the TIE is no longer flat. It is a sinusoidal shape with random noise on it. If you have experience with electronics, noise is inescapable. So random noise will still be there, but the jitter that I injected was sinusoidal, and therefore you get this shape here. Even in the smooth TIE, you still get that noise that comes through. If you go out to a longer time scale, you might see it in a smoother sinusoid. And what happened to the spectrum is you still see this baseline humped shape, but now that you see a really large spur in the beginning here. And we can turn on cursors after this to find out what that spur is. It'll be an interesting result to you when you find out what the spur is. Also, you will notice that the histogram has a different shape. It's no longer Gaussian. It has this dual Dirac shape with this valley in between, and that is the typical histogram of sinusoidal jitter. So yeah, let's stop the oscilloscope because we have a pretty good histogram and spectrum here. And let's turn on the cursor so we can measure what that peak spur is in the TIE spectrum. We need to change the cursors to track waveform. I'm just going to use one X1 and Y1 cursor, and I'm going to put it on the FFT, which is the TIE spectrum. So I'm going to drag it till it sits right on that peak there. Yep. And what you'll notice is it's at exactly 1 megahertz, which was the frequency of that sinusoidal jitter that I injected. So these are the tools available to you to identify what jitter components are in your signal. And the 6000X InfiniiVision series oscilloscope is the only embedded oscilloscope that can do this. What it gives you is a way to see the jitter correlation in time, the jitter spectrum, so you know exactly which frequencies it's showing up, and also what sort of jitter and how it affects the time interval error histogram. Usually you don't have one component of jitter, you have a few different ones. So this histogram may appear very random, but you can slowly go into your circuit and start removing effects of the jitter one by one, and you would notice removing those components would change this histogram shape. So that way you can identify the problems in your circuit and find out how to resolve them. So once you have a good plot like this, you can turn on labels just so it help um, you discuss the issue with your colleagues. Math through is just the TIE, so I'm gonna type in the TIE and click apply. And math 3 is the smooth TIE. And I'll change the final math 4 to be TIE spectrum. Of course, the spectrum is down here, but the label's up here because of the dB scaling. And that's the end of the video. I hope you enjoy it, and please contact Agilent Technical Support should you need any help using this tool.